Hi there, Algebra 2. 5.6, Fundamental Theorem of Algebra. Use the fundamental theorem of algebra to solve polynomial equation with complex solutions. The degree of a polynomial equation tells you how many roots the equation has when you have a polynomial of degree 2. There's 3 possible solutions. If p of x is a polynomial of degree n greater than or equal to 1, then p of x equals 0 has exactly n roots, including multiple and complex numbers. Alright, so last lesson we learned how to find kind of the x value of our roots. Okay? And we're going to do the exact same thing. We have to have the equation of constant over leading coefficient. And these are going to be factors, as if you can remember from the other day, that this is 1 and 1. Okay, this one has 1 and 4 and 2 and 2. Okay, so the other thing you need to remember is when you do these, so I'm going to have constant of 1 over 1, and it's going to be plus or minus, so we have plus or minus 1. Okay, now we have, we're going to go plus or minus. Well, our next factor for constant is 4. All my leading coefficients factors are 1, so I'm going to get plus or minus 4. Alright, I'm going to get plus or minus. The next one would be 1 or 2 over 1, which is going to give me plus or minus 2. The next one would be 2 again, which I already have established. Okay, at this point, I tried to make your guys' life easy. You couldn't have to sub in every one of those. But Mr. Rito doesn't want to be that mean. You are going to go second. Turn it on first. So, we're going to go second. Or no, we don't even have to go second. We're just going to go y. We're going to plot an equation. So, to get x to the 5th, I'm going to have to hit this x, so right by the link. Then I'm going to have to use my caret key, which is right there, to the 5th. Caret key was right here. Alright, to the 5th. Minus. I got to make sure I'm down, so I got to hit over. Minus x raised to the 4th minus 3x. Minus 3x raised to the 3rd plus 3x raised to the 2nd okay, plus, no, it's minus 4x plus 4. Okay, now I'm going to go second window, which is going to give me table set. I'm going to go 1 and 1. Now I'm going to go second table. I'm looking for values in which y equals 0. So 1 and 2 are both factors of these. They're both roots. Okay? Now, the reason that we're looking for these zeros, or y equals 0, is if you remember a square, or a root, is going to be x minus 2 equals 0. Well, we're saying this y, which could have been subbed in from here, is 0. So when we solve this, we're finding out what x equals when y is 0. So that's why we look for on our calculator zeros. Okay, now at that point, we then go and we're going to do synthetic. Okay, I'm going to take 1. 1 was the first one I seen, so I'm going to go 1. Factor is 1, minus 1, minus 3, plus 3, minus 4, 4. Bring this down. I get 1 1 times 1 is going to give me 1. So I'm going to get 0 here. Alright, then I'm going to plug this in, and I'm going to get 0 times 1, which is 0. So I'm going to get negative 3. Negative 3 times 1 is negative 3. That's 0. 0 there. Negative 4. 1 times negative 4 is going to give me 0. And there I have it. Okay? So, reduce my roots by 1. You have x to the 4th, x to the 3rd, which isn't going to add anything. This is going to be x to the 2nd, x, and nothing. And this is my remainder. Okay? So I realistically have x to the 4th minus 3x to the 2nd minus 4. Now I have to think. I could do synthetic because we've seen a 2. If we go synthetic, you got to remember though, you need these spaces of 0. Or I can see if I can factor this. I'm going to get x to the 2nd, x to the 2nd. Okay? And see if I can factor it. I got to have a plus minus is what I'm seeing here. My minus is here. So that's telling me that's got to be the bigger one. Factors of that are 4 and 1 and 2 and 2. We already talked about that. I'm going to go probably minus 4 here and 1 here. If you would FOIL in outside, you get negative 4x to the 2nd. Inside is going to get me plus x to the 2nd, which is going to give me 3x to the 2nd. So I did that good, or I factored that correctly. Okay, now, can I factor either one of these? Well, this one I can, and I'm going to get x and x. That's going to give me plus minus. This is going to be a factor by different squares, or different, what is it? Difference of squares, I believe is what it's referred to as. I'm going to get 2 and 2 here. That's the only way that these can cancel out, is if both of these are the same, only different is their signs different. That's why there's no middle. Okay? So I've got this, so I have x. If I solve this for a root, it's going to get me negative 2. X equals 2. Alright, so at that point, now we know that we got 2 roots. I need a total of 5. Well, I know over there, this synthetic division, that was a factor. That's why it worked when I divided. So I have n equals 1. That's another one. Now I got to work with this. Can I do this? Well, I'm going to just set it equal to 1 right away and see what happens. Or not 1, 0. So I'm going to get negative 1 x to the 2nd equals negative 1. Okay, now I can square root that. So I'm going to end up with x equals plus or minus the square root of negative I, which is x equals plus or minus I. Okay, this is plus or minus, so that's worth 2. There's 3. There's 4. There's 5. Got all my roots. That is exactly what you're trying to do on these. Okay? Now, what are the roots of this equation? You have x to the 4th plus 2x to the 3rd equals 13x to the 2nd minus 10. I'm going to try to get all this to one side. So I'm going to minus 13x to the 2nd to both sides. I'm going to end up with x to the 4th plus 2x to the 3rd minus 13x to the 2nd equals negative 10x. I'm going to add 10x to both sides. Add 10x to both sides. I'm going to get x to the 4th plus 2x to the 3rd minus 13x to the 2nd plus 10x equals 0. Okay? At that point, I'm going to take an x out of everything. So I'm going to get x to the 3rd plus 2x to the 2nd minus 13x plus 10. I want a constant is why I did that. Okay? If I had to set this equal, we know that x is going to equal 0. So there's one root already. I'm going to put that over here. Because if I set this equal to 0, because I'm going to set all this equal to 0, x could possibly equal 0. There's one row. Okay, now I'm going to go and I'm going to type this into my calculator. Okay, first thing I'm going to do is clear that. I'm going to go x, and I'm just going to type in the part that's in parentheses, x to the third plus 2x raised to the second minus 13x plus 10. Okay, second, I'm going to go graph or the table button up here. Okay, I have 1 at 0 and 1 at 2. Okay, so 1 and 2 again. Oh, I have those, and those should work because of the fact that my coefficients again are going to be 1 and 1, or leading coefficients are going to be 1 and 1 and 10. So your possibilities on that are going to be 1's going to be on the bottom again. Then you're going to have 1, so that's going to be plus or minus again. Once again, constant over coefficient. So we got 1, so that's going to be plus or minus 1. You're going to have plus or minus 10 over 1, which is going to give me plus or minus 10. Then you get plus or minus, you're going to get 5 over 1, which is going to give me plus or minus 5. And then plus or minus 2 over 1, which is plus or minus 2. Okay, so those were my options. One worked. Okay, so I'm going to use synthetic division based off of that. So I'm going to go back to using this because I've taken care of that row. So I'm going to get 1, 2, negative 13, and 10. Okay, my factor is going to be 1 in here. So I'm going to bring this down. I'm going to get 1. 1 times 1 is going to give me 1. So that gives me 3. 3 times 1 is going to give me 3, which is going to give me negative 10. Times 1 is going to give me negative 10 remainder. Okay, now I have 1. So this is going to be x to the second, x regular. So I have x to the second plus 3x minus 10. Can we factor that? I believe so. We're going to get x and x. You're going to have to have a plus minus. This plus is telling me that the plus is probably going to be bigger. I'm going to go with 5 and 2. Do outside, get negative 2x. Inside is going to give me plus 5x, which is going to give me 3x. Alright, I did my work correctly. Okay. So, I'm going to come back now, and I'm going to set each one of these equal to 0, which is going to give me x equals negative 5, and x equals 2. 1, 2, 3, and this is a factor in which x equals 1. There's my fourth one. Okay, next slide. Alright, now we're going to do these a little bit different. There's always another way you can do these. This one is called graphing. Okay? In which case, your calculator, you do the exact same thing. Or, we could go back to our old familiar Desmos. So, once again, you'd clear that. You'd put x to the fourth plus x to the third. Plus x to the third. Okay, minus, gotta get out of that top, minus 7x minus 9x minus 18. Okay, graph. So we're just going to, instead of go second graph, we're just going to go straight to graph. And we're going to get something that looks like that. Now I can't actually see the bottom of my deal here, so I'd have to change my windows, which means I'd have to go here. Let's go negative 25, let's go 25, and let's go, the y value might have to be closer to 30. Oh yeah, let's see what we get. Can we see it all now? Still should probably go lower. Now, the one thing that I don't like about a calculator and I like about Desmos is the fact that tracing it is not real easy. Now, if I go to Desmos, and I put x raised to the fourth plus x raised to the third minus 7x raised to the second minus 9x minus 18. Okay, you have these two spots that crosses the y-intercept, or the x-intercept. These are going to be two of your roots. So now I have two of my roots. Now I can just go in and I can use synthetic based off that. So negative 3, 3. Okay. I'm going to use synthetic here. So you're going to have, you can take negative 3. Okay, we're going to have 1, 1, negative 7, negative 9, negative 18. Alright, 1 comes down, 1. Alright, times negative 3 is going to give me negative 3, that's going to give me negative 2. Take that times that, that's going to give me 6, which is going to give me negative 1. Okay, which is going to give me a positive 3 here, which is going to give me negative 6, which is going to give me a positive 18 here. We get 0. So if you went back in, this would be x to the third minus x to the second minus 1x minus 6. Okay, I don't know if I want to factor that. It's to the third, and it isn't one of those nice ones to the third that'd be cubed, either subtracting in the middle or adding. So I'm probably not going to want to go with this route. So I'm probably going to try to use synthetic again. So you're going to have that 3. We have 1, negative 2, negative 1, negative 6. Going back to this one now. So we've already factored one thing out of there. I bring this down, I get 1. 1 times 3 is going to give me 3. 1, 3, that's going to give me that. It's going to give me a 2, which is going to give me 6. Now I'm left with x to the second, x, and that. So we're at this point now. So, two of my roots are x equals negative 3 and x equals 3, because they factored out. Now, the reason we can't see the other ones on the graph is because they're imaginary. So at this point, I would have to probably do my quadratic equation. We're going to get negative 1 plus or minus the square root of 1 squared, which is going to give me 1. times, or minus 4 times a, which is this one, which is still going to give me 4 times 2, which is going to give me 8. Alright, all over 2a, 2 times 1 is going to be 2. So then I get negative 1 plus or minus the square root of negative 7 over 2. And this is my other set of roots. There's 2 because of the plus or minus. I needed 4. There's my selection. Okay? Alright. I'm not going to do the other one. It's already been a 20-minute video, and I'm sure you didn't want to hear me that long. The fundamental theorem of algebra. Here are the equivalent ways to state the fundamental theorem of algebra. You can use any of these statements to prove the other. Each polynomial equation of a degree n is greater than 1 has exactly n roots, including multiples and complex numbers. Every polynomial of degree n is greater than 1 has a linear factor. Every polynomial function degree n greater than 1 has exactly 1 complex 0. There is your homework.